about Principle of Steel Design. By the way, I am Lanny Berja, third year Bachelor of Civil Engineering from University of Southern Mindanao. We have AISC, Load Combination. AISC stands for American Institute of Steel Construction. We have two load combination, LRFD, or what we call Load Resistant Factor Design. On the other hand is Load Combination, or ASD, Allowable Strength Design. As you can see, the wind load and earthquake load is separate because never in phenomenon na nagsabay sila, but it has possibility to happen. The given load combination, D is for dead load, L is for live load due to occupancy, LR is roof leaf load, S is snow load, R nominal load due to initial rainwater or ice exclusive of the pending contribution, W is wind load, E is earthquake load, and so on. Let's go to the given problem. So problem 1, a column in the upper story of a building is subjected to a compressive load from the following sources. Dead load is equals to 30.0 kilopascal, occupancy live load is 1.7 kilopascal, roof leaf load 18.7 kilopascal, and snow load 19.7 kilopascal. Here the problem. Letter A. If load and resistance factor design is used, determine the factor load required strength to be used in the design of the column, which AISC load combination controls. In our past slide, so sa ating problem is wala na naman tayong wind load at saka earthquake load. So for C1 is nakakuha tayo ng 43.12 kilopascal, then C2 is 49.53 kilopascal, then C3 is 69.33 kilopascal. If we continue this equation, is mas maglas pa ang ato ang kilopascal. So my answer is combination 3, 69.3 kilopascal. What is the required design strength of the column? Since ultimate strength natin is 69.33 kilopascal, then ang ato ang required design is 69.33 kilopascal. So in letter C, what is the required nominal strength of the column for a resistant factor of 0.90? So ang ultimate strength is 69.33 kilopascal, then ang required design is 0.90. Then, ang atong ultimate strength is 73.03 kilopascal. Then, letter D, if a lower ball strength design is used, determine the required load capacity, required strength, to be used in the design of the column, which AISC load combination controls. Then, nag-use na po ta og LRFD, load resistant factor design. So, C1 is nakakuha tag 30.8 kilopascal, C2, 32.5 kilopascal, C3, 50.5 kilopascal, C4, 46.85 kilopascal. So, if we go on our solving, mas maglas pa ang ato ang C5 and so on. Then, sa answer is combination 3, which is 50.5 kilopascal. Letter E, what is the required nominal strength of the column for a safety factor of 1.67? And our required strength is 50.5 kilopascal, then in safety factor is 1.67. So, the formula is given na. So, we must equate to get the nominal strength. So, i-substitute lang nato siya ang mga given value, then the answer is 84.34 kilopascal. Problem number 2. A column is subjected to the following load. Dead load is equals to 26 kilopascal, occupancy live load 15 kilopascal, roof live load 5 kilopascal, snow load 8 kilopascal, rain load 5 kilopascal, and wind load 8 kilopascal. All loads are compression except for the wind load, which can be either tension or compression. So we have our given. So letter A, if load and resistance factor design is used, determine the factor load required strength to be used in the design of the column, which AISC load combination controls. So C1 get 36.4 kilopascal, C2 59.2 kilopascal, C3 51.5 kilopascal, C4 is 50.7 kilopascal. So ang mas highest is 59 kilopascal man. So the answer is combination 2, ultimate strength 59.2 kilopascal. So letter B, what is required design strength of the column? So our ultimate strength is 59.2 kilopascal. Then our required design is 59.2 kilopascal. Letter C. What is the required nominal strength of the column for a resistance factor of 0.90? We have our ultimate strength 59.2 kilopascal, then our required design 0.90. So our formula is given already. Then we have to inequate. Then we have to substitute the given value. So our nominal strength is 65.78 kilopascal. B. Letter D. If allowable strength design is used, determine the required load capacity, required strength, to be used in the design of the column, which AISC load combination controls. So we have here the C1, 26 kilopascal, then C2, we have to substitute, we get 41 kilopascal, then C3, 34 kilopascal, C4, 43.25 kilopascal, C5, 30.8 kilopascal, C3, we get 46.8 kilopascal. Then the highest among is C6, we get 46.85 kilopascal, and that's the answer. Then, letter E, what is the required nominal strength of the column for a safety factor of 1.67? We get the required strength is 46.8 kilopascal. Then our safety factors, which is given 1.67. Then we have our formula. Then we have to inequate to get our nominal strength. So we have to substitute the given value, then we get the nominal strength, which is 78.24 kilopascal. Then problem number 3, the load on the roof beam consists of a dead load of 0.2 kilopascal feet, a roof live load of 0.13 kilopascal feet, and a snow load of 0.14 kilopascal over feet, and are given. So letter A, we have if load and resistance factor design is used, determine the factored load required strength to be used in the design of this beam, which AISC load combination controls. Then again, we have the C1, 0.28 kilopascal, and so on, just only to mm, substitute the given value. So our answer is combination 3 because this is the ultimate strength 0.46 kilopascal over feet. Letter B. If allowable strength design is used, determine the required load capacity required strength to be used in the design of the column which AISC load combination control. As you can see, C1, C3, C4 only because I just want to show you kung ano yung mas mataas na required strength. So, our answer is combination 3, required strength 0.34 kilopascal over feet. Then number 4, beams will be designed for the roof and floor system of an office building. The loads for this system are as follows. Roof, dead load 30 pounds per square foot. Roof live load 20 pounds per square foot. Snow load 21 pounds per square foot. And a rain load consisting of 4 inches of water. Floor dead load is 62 pounds per square foot and occupancy live load 80 pounds per square foot. So letter A, for each of these system, determine the required factor load capacity for LRFD which load combination controls. So separate natin ang roof at saka floor pag pag-answer. So we have here the given. D is equals for 30 pounds per square foot. Then roof live load is 20 pounds per square foot. S is 21 pounds per square foot. Then R is rain. Then 4 inches sa may water. Then convert natin ang inches into 4/12. Water is 62.4. So ang R na natin is 20.8. So ang combination natin is tatlo lang din. So ang mas higher is ang combination 3 which is 69.6 pounds per square foot. Then sa floor, we have a 2 combination lang. Then ang mas higher is ang 202.4 pounds per square foot. Letter B. For each of these systems, determine the required ASD load capacity, which load combination controls. Roof given is B is equals to 30 pounds per square foot. Then roof live load 20 pounds per square foot. Then S is 21 per square foot. Then sa rain is ang para sa katulad lang kanina kung ano ang ginawa natin, then rain is equals to 20.8. Then we have here is C1 then C3. We just want to identify kung ano yung mas mataas. So combination 3 is ang mas higher. So we have 51 pounds per square foot. Then sa floor, we have here C1, C2, C4. As usual, we have to find kung ano yung mas mataas. So we have here the combination 2, 142 pounds per square foot. Problem number 5. Structural steel buildings frequently are designed with diagonal bracing system to resist lateral loads, horizontal forces resulting from wind or earthquake load. A certain bracing system is subjected to the following loads. Dead load is equals to 13.3 kilopascal, occupancy live load 6.9 kilopascal, roof live load 1.3 kilopascal, snow load 1.3 kilopascal. Then wind load is 150.6 kilopascal and earthquake load is 161.1 kilopascal. Then letter A, then determine the required factor load capacity for LRFD, which load combination controls. So, i-distribute lang natin yung mga given. So, we have here the ultimate strength, which is combination 5, 180.8 kilopascal. Then letter B, determine the required ASD load capacity, which load combination controls. Then given is we have D equals to 13.3 kilopascal, L is equals to 6.9 kilopascal, LR is which is roof live um, roof live load 1.3 kilopascal, S is 1.3 kilopascal, then the W is 150 kilopascal, E which is earthquake 161.1 kilopascal. Then mas mataas yung combination natin because higher ang required strength, which is the combination 5, 126.0707 kilopascal. That's it for today. Thank you. Thank you for listening.